Okay, so today's session is create drive time areas and perform drive time distance analysis. And joining me today will be Jack Wang, Director of Software Development for Spatial Graph, and Sean Tai Hu, Senior Member of Technical Staff. And just a couple more slides. Jack, next. Just in case some of you aren't familiar, spatial features have been in the database for over 25 years. We have a very comprehensive and robust portfolio. We store, manage, process, and analyze spatial data types in the database, starting from basic types like points, lines, and polygons, all the way to these more advanced types, such as a network data model, which we'll be hearing about today. We also have mid-tier deployable components that work with these spatial data types, including mapping, geocoding, routing, web services, and Spatial Studio. Next slide. And just another slide before we begin, just again, in case you aren't familiar with this, since last December, spatial features of Oracle Database no longer require the spatial graph priced option. Everything is included in the database. All features, including network data model. This includes, autonomous database as well. So Enterprise Edition, SE2, all cloud database offerings, all free. And one note here that I did want to point out, network data model will be an autonomous database and Oracle Cloud Marketplace in Q1 of next calendar year. So I think we are ready to go. Jack, I'm going to hand it over to you. And you're up.
Okay, thanks, Carol. Okay. Today's agenda for our Ask Tom office hour session is the following. First, I'm going to give an introduction on drive time and drive distance analysis. Then I will talk about network data model, which we are going to use for our drive time and drive distance analysis. Then I'm going to talk about how to use a feature in network data model called network buffer. And I'm going to talk about the representation of network buffer. I'm also going to talk about how to use network buffer to define the drive time area and to perform drive time and distance analysis. Then we are going to show you a couple of demos on network buffers. And we're going to give you a step-by-step tutorial. We're going to show you the Java code and some SQL script to do the drive time analysis. Then I'm going to wrap up of our presentation. Okay. Drive time and drive distance analysis is an important task for many GIS and business analytics. And some of the common use cases are the following. For trade area analysis, for instance, if you want to know your customers within 20 minutes of drive time, and for marketing and sales planning, you want to know the customers of a specific demographic data within a given drive time or distance. You can also try to figure out your current and potential competitors with the competitive analysis. And in transportation and urban planning. So for instance, you can find out the area of coverage of certain transportation facilities like airports or buses. And for emergency response, like a police department, fire department, or hospitals. And there's also vehicle tracking application that we typically see with like a geofencing type of application, or sometime in fleet management, you want to track the driver's behavior. Okay, before we talk about how to do drive time or drive distance analysis with NDM, first I'm going to give you a quick introduction on network data model. Network data model is a spatial feature for network modeling and analysis. So network data model, we store network data in the database as node and link tables. And we have a NDM Java API that lets you perform network analysis. And we provide the following network analysis functions. For instance, the shortest path, reachability analysis, drive time or drive distance analysis, and the optimal multiple stop route, which is typically known as traveling salesman algorithm. Network data models also supports business logic, so which can be implemented as a network constraint to guide the network analysis. You can also include your own business data as a user data into the network analysis. And we support multiple costs. It can be drive time or distance or number of hops. In this slide, I show you a typical three-tier architecture for a typical network data model application or service. On the left-hand side, you have the backend storage. It's an Oracle database, so where you store NDM data, and also you can have raw network data stored in the database. And in the middle tier, this is application layers where we use NDM Java API to perform drive time analysis. In addition, you can have a geocoder service or map visualization service. And on the right-hand side is a typical front end, is a web browser for user as a user interface. And later we're going to show you the demo. So is a typical three-tiered NDM application. Okay, now let's talk about how we can conduct drive time or drive distance analysis with NDM. So we use what we call network buffers. Network buffers is a representation that provides coverage and minimum cost information to or from buffer center. And the buffer center usually are your target point of interest. For instance, the store or the department or restaurant. And network buffer consider network cost, not the spatial distance in the analysis. So this is different from spatial buffer. And we pre-compute network buffers and persist network buffer in the database for subsequent drive time or drive distance analysis. And we can perform our cost and shortest path query only with a SQL statement. And the unique things about network buffer is it does not require spatial or network analysis, just a simple SQL query or join. And network buffers can greatly reduce the number of shortest path analysis. On this slide, I'll just do a simple comparison between a spatial buffer and a network buffer. So spatial buffer use spatial distance as a cost. And the network buffer, you can use any network cost. You can use travel distance or travel time as the cost. The representation for a spatial buffer is typically a polygon or polygons. And network buffer is just a set of cover link and the cost in a table. How do you query a spatial buffer? You have to use some kind of spatial function, like a point in polygon, in order to know whether a point is inside a spatial buffer. But for a network buffer, you can simply just use a SQL statement to query the cover link table in the database. The performance of a spatial buffer depends on the complexity of the buffer geometry and the number of locations you're going to query against the spatial buffer. And the performance for a network buffer is very efficient because we only need to do a simple SQL query against the cover link table with simple linear interpolation. And this is very suitable for large-scale drive time or drive distance analysis. And the coverage and cost information in spatial buffer. In a spatial buffer, you only know whether a point is inside a spatial buffer or outside a spatial buffer. You don't actually have the cost information. But while for a network buffer, you can have both coverage information. If a location is covered by a certain network buffer, you can also know the actual network minimum cost information. And on the right-hand side, it's a simple picture showing you a typical spatial buffer of 3 kilometers. If you see the blue circle, that's a typical representation. And inside, there's a very colorful copper links. That's actually the network buffer representation in a spatial way. Okay, how do we represent network buffers? So there are 2 kinds of representation. The first one is in-memory Java representation. Since network buffer, we use the NDM Java API to support network buffer. And we also provide a database representation for network buffers. This is a representation we're going to focus today. And the database representation contains 2 parts. One is the metadata information about network buffers. The other one is coverage and cost information. So the network buffer information contains the following: a buffer ID, which is a primary key to represent each buffer. The buffer direction, it can be forward buffer or reverse buffer, depending on whether you're going out from the buffer center or coming into the buffer center. You can also have the buffer radius or buffer cost defined. And another metadata is the buffer ID with respect to its buffer center. And you can have a single buffer center or multiple buffer center. In our demo, we're going to show you 2 different kinds of buffers. One is a point buffer, network buffer. The other one is a linear network buffer. For the coverage and the cost information, this information show you all the cover, node, and link of a particular network buffer and its cost information. And this is the primary tables we're going to use for drive time analysis query. This slide shows you the database representation for network buffer for its metadata. On the left-hand side, you see there's a buffer ID, radius, and direction. So we have 12 buffers representing 12 stores. And the radius is 600 seconds. Actually, it's 10 minutes drive time. And the directionality is backward, meaning from any location going into the buffer center, like the customer going to the store. On the right, you see the buffer center information for each buffer. Again, there are 12 buffers, and each buffer center, here we are using network representation with a link ID and a percentage to represent the buffer center. On this slide, we show you the cover link information of a network buffer. So this, we show you for buffer ID 1. So it's part of its link ID. And the previous link ID let you find out the shortest path if you want. And for each cover link, it has a start and end percentage, depending on how the cover link is fully covered or partially covered. And also it has a start link and end link, which can be used when you want to get the accurate minimum cost for any given location on this cover link. Okay, so we just give you some introduction on network buffer. So now let's talk about how do you create a network buffer. So we can use NDM Java API to create a network buffer. So you can see inside the red rectangle, the first line is, first you define a buffer center with the link ID and its percentage. Second line, you just call the network buffer function to create a, in this case, you are creating a reverse or what we call reaching network buffer. And finally, you can just write the network buffer into the database. And that's it. Okay, so when you create a network buffer and store them in the database, you can query a network buffer with a SQL query. And this is a simple SQL query you can do. You can query a location against a specific buffer. In this case, we are querying against the buffer 1 with the location in a network representation, link ID 799415310, and its percentage is 0.771812. And the result actually show you is the minimum cost from this location to buffer 1 is about 567 seconds. It's a little over 9.5 minutes. In this example, you can do the same thing, but you can query against multiple network buffers. So the same location, and the result will return all the cover buffers. So right now there's 11 network buffer cover the given location, and their minimum cost in a certain order. Or in some cases, you are also interested in getting the shortest path, not only the minimum cost from a location to a buffer center, but you are also interested in finding out the shortest path, maybe for visualization purpose. So if you recall, in our previous slides, we have a previous link ID information that you can use for you to construct shortest path. So you can use a hierarchical SQL query, start with connect by, and you can retrieve the shortest path link information. So the result only show you the path link ID. But if you have the link ID geometry, you can join it, and you can get the shortest path geometry information as well. Okay, so I think that's pretty much about the introduction I'm going to give. So I think later my colleague Shantai is going to give you a couple of demos. And the first demo is the nearest POIs in location-based service. So the analysis area is San Francisco, and we are using here raw network data. The target POIs is 12 convenience stores, and we define a 10-minute drive time for each store. And what the demo will show is if you click on any location, it will return the nearest store. So here's a snapshot of the first demo. In the picture, you can see the red star. When you click it, then it will try to find all the cover store and also compute the shortest path. And in the middle, you can see all the store and their drive time to these store. On the right-hand side, they are the SQL queries we just mentioned, and they are used to implement this demo. Okay, so the second demo we're going to show is vehicle deviation detection. This is commonly seen in fleet management. So our analysis area is San Francisco, and our target POIs. This is different from the previous demo. Previous demo is a point network buffer. But in this case, we have a predefined route. So we use all the points on the path that we define. So it's a little over 200 points for this predefined route. So we define a network buffer with around 200 buffer centers. And then we define a 5 minutes drive time along the predefined route. In the demo, whenever you click on any location, it will return you the nearest exit of the pre-planned route. And in addition, if you define a drive time threshold, if the location is beyond the drive time threshold, it will give you some kind of a warning to let you know the vehicle has deviated from the pre-planned route. So this slide on the left is show you the picture. So the purple line represents the pre-planned route. And we show you the 1 minute. Here we are using a threshold 1 minute drive time. And we show you the drive time area. As you can see, when you click on the map, you show these green stars. So if it is inside the drive time area, nothing is going to happen. But if it is outside, so you can see the red circle, and that actually are alerts that the vehicle has deviated from the pre-planned route of more than 1 minute drive time. On the right-hand side, the same things about the SQL query that are used for this demo. So I think I'm just going to hand over to my colleague Shantai. He's going to show us the demo. So Shantai?
Yep.
I will stop.
Okay. Can you see my shared screens?
Yes.
Okay. So let me walk you through the two demos Jack has mentioned in the slides. The first one is called Store Customer Analysis. This demo is trying to demonstrate a usage when you have a list of fixed endpoints or destinations around San Francisco area, and you may curious what's the minimum cost from a given location to any of the fixed endpoints. In this case, there are convenience stores. You can see there are 12 buildings around this area, and each one has a predefined network buffer with 10 minutes drive cost range. In this demo, you can either input a longitude or latitude or pick up a point on the map. You can select how many times you want to drive to access a store. In this case, let me pick this point. You can see that there are 9 stores were found within 10 minutes drive. And you can see all the shortest path result has been displayed on map. Also, the street address of the input location and the network representation over here. The stores are sorted by its driving cost. You can also see the network representation here. You can see that the performance to analyze the network is only 7 milliseconds. The time to compute geometries is 94 milliseconds. They are kind of fast is because the minimum cost is already pre-calculated and saved to the database. All we need is to query the database to get the minimum cost and path geometry. The first query we're using is to get the minimum cost from a given location, the star location here, to all the network buffers. The second one is trying to retrieve the link information of the path. This is the first demo. The second one is called Network Buffer Vehicle Tracking Analysis. As Jack mentioned in the slides, it can use in fleet management, and you want to see if a vehicle is driving on its planned route, or it has a deviation, or how long it needs to get back to the planned route. And in this case, we predefined 2 planned routes. Each one is a 1 network path buffer Each buffer has around 200 buffer centers. This demo is trying to demonstrate if you have a list of endpoints and it doesn't matter a given location need to get back to which endpoints. As long as to get back to the route, it should be fine. So you can pick a point around here and can see the minimum cost to get back to the route is 3.6 minutes, and the shortest path on the map as well. We can also show the covered links polygon in this demo. In this case, the threshold in minute is 1. So the polygon we see here is a 1 minute covered link branch. So if the vehicle is within the polygon, there is no alert at all. When it's off the route, like 2.6 minutes away, we will see alert. We can also keep previous result so you can have a better idea how this works. In this demo, we also have a moving simulation. In the simulation, we're trying to show you there is a moving vehicle driving along the planned route and keep sending its real-time location to the server. And once it has a long deviation from the planned route, we can see there is an alert. I can also enable the polygon display and do the simulation. You can see when the vehicle is driving outside the polygon, we'll see the alert. Thanks to the network buffer technology, basically we save all the minimum cost from cover links to the buffer, network buffer centers. So it's pretty fast to get the minimum cost and shortest path information. And that's about these 2 demos. Let me hand over to Jack.
Okay, thanks, Shantai. Let me share my slides again. Okay, so can you all see my slide now?
Yes.
Okay, so next we are going to show you how to do a step-by-step tutorial to create network buffers and perform drive time and drive distance analysis. So in the tutorial, so there are 3 major steps. The first one is we have to convert location information into network representation. And typical location information is either address or GPS location like longitude, latitude, location information. And you can use geocoder or reverse geocoder to convert these location information into network representation, which we're going to use for our drive time and drive distance analysis. Once you have the location information, you can generate the network buffers and store them in the database. So we're going to show you Java sample code that you can do so. And we are also going to show you some of the network buffer tables in the database. And the third step is once you have the network data, once you have the network buffer tables in the database, you can conduct queries to find out the minimum cost and the shortest path from any location to the buffer center with SQL queries. So Shantai, I will hand it over to you so you can show us the tutorial.
Yeah, sure. So can you see the shared screen now? So, okay, let me walk you through the 3 steps of the complete workflow utilizing the network buffer. The stage 1 is about geocoding and reverse geocoding. because usually you need to start with a street address or a longitude and latitude information. So when you get a street address, you can use SDO GCDR package, geocode, and the reverse geocode function right here. You can simply pass the street address for geocode result. You will see this is a large object which contains a lot of attributes. So you need to extract necessary information from it. In this case, you need to extract geocoder result representation, which is edge ID, percent, roadside, longitude and latitude. So when you have a longitude and latitude information, you need to do a reverse geocoding. Basically, the results are the same. You can still have the street address and network, the geocoder representations. After that, you can do the rest. So for example, in the first demo, you may start with a list of street address, such as you have 12 street address over here. And then you can use this query to extract necessary edge ID, roadside, and percent. And then you need to do a small transfer because network data model link is directional. So you need to transfer the edge ID with roadside to link ID using this query. After you get the link ID and percent, we can start to create network buffers, which is the stage 2. Let me show you the Java sample code right here. When you have the link ID and percentage, you can initialize a network representation of location, which is point on net in this case. And then you call reaching network buffer. You can see that this function takes 3 parameters. The first one is an array of network representation location. The second one is cost range. The third one is network constraint. In our case, you only need to specify the buffer centers and the cost range. You can see that the function name is reaching network buffer because you can also specify directions by calling network buffer or reaching network buffer. Reaching network buffer means the buffer centers are the end point when routing, and vice versa. After you get the Java object, you can use write network buffer, passing in the buffer instance, specify an integer buffer ID, and a string table name prefix, and then the network buffer tables will be generated. Usually in a generic 16 gig RAM Linux box, generating a 10-minute drive buffer only takes 1 second. So in our case, it takes 12 seconds to generate the 12 network buffers for the convenience stores. As Jack mentioned in the slides, these two are the metadata of the network buffer. You can see there are 12 buffer with radius 600 seconds with backward direction. And this table is network buffer cover links, which has the network representations. And this one is the coverage table, which has cover link. You can have a look at the schema. Each entry has a link ID and its previous link ID with start percentage and end percentage, the start cost and end cost. That's why we say we only need to submit SQL queries if we have a given location and we are going to have the minimum cost from a link to a specific buffer. And you can have a look at the numbers of each buffer covered. Comparing to the total number of the link table. This is the link table. The total number is 13,300 links. And each one is having like over 10% of the links. We can also have a look at the path buffer. The first one is this metadata table. We only have 2 path buffer in our case, and they have same radius and backward direction. The number of buffer centers we can see, since there are path buffers, we're basically passing in the path shape points as its buffer centers, and they have around 200 buffer centers for each path. We can see that the number of cover links for each path buffer, and even the shape points are close together. Our path buffer doesn't have redundancy cover links. So once we have an idea of the network buffer path table and point buffer table, we can query network buffers. How do we get the minimum cost? We need to specify a given location by its network representation using link ID and percentage using this query. To get the cost, we need to do a simple linear interpolation to get an accurate minimum driving cost in this case. We can also query all the costs to all buffers from given location. To visualize the shortest path between a given location to buffer centers, we need to first get the list of links, because path consists of segments, links. So using this query, we can get list of links. We can see that each link has a pref link. When the previous link ID is null, it means this link is exactly the link the buffer ID 1 located. And at the end, the first ID is the starting link. This is how we get the list of links. So after we get the list of links, we can join the result here with the network link table, which consists of link ID and link geometries. After that, we use SDO aggregate concat lines to create the path geometry. You can see this object contains the necessary coordinates we need to visualize on the map. So we can extract the coordinates from it. And then we can do the visualization on the map. Okay, that's pretty much it. Let me hand over to Jack again.
Okay, thanks, Shantai. So that's pretty much it. I would like to summarize our presentation today. So in our presentation, we showed how to use NDM, in particular network buffers, for drive time and drive distance analysis. And we show you how you can create drive time areas with network buffer, and how you can perform drive time or drive distance analysis with a SQL query without using any spatial or network analysis. And we also present a couple of demos on the nearest store and for vehicle tracking. And we also provide a step-by-step tutorial with Java code and the SQL scripts that show you how you can achieve this with network data model. I think that's pretty much it. So let me go to the, I think we have one resource page I want to go to. So there are certain resources that are available for our presentation. You can get a NDM demo information from the URL, and the spatial feature homepage is also listed. And we have a YouTube channel, blog, any other social medias that you can use.
Right, we don't have many questions today, but someone did ask about the demo assets. And after this session in the near future, we'll be posting its location. So we'll let you all know that. You can also, contact us if you need it in a hurry, and we can tell you how quickly we can get it posted. So if there are not any more questions right now, I think that's it. We thank you for joining us. Hope you learned a lot. Just be aware this will be posted in Ask Tom for recording, or if you want your colleagues to record to listen to it, and there'll be future sessions as well. Great. Thank you very much, everyone, for attending.
Okay, thank you.